Good evening, everyone. Very good evening. Okay. Okay, your counselor is here. Okay, first we shall have a requirement announcement. Okay, then we shall resume back. Yes, Vandana, you can carry on.
Thank you, ma'am. Good evening, guys. This is Vandana from the announcement team. Is my voice is audible? Uh, guys, is my voice is audible? Okay. Guys, today we don't have any requirement announcement. We had only batch announcement. I've shared you the batch link in the broadcast. Hope everyone received. Guys, Java Selenium classes will be starting from 26th October. Timing will be evening 7 to 9. For that, testing student code Java should be completed. And if you guys completed 90% of the course, you can attend the classes. If you have any queries, guys, please let me know. Okay, guys, these are the updates for the today's class, guys. Thank you, guys. Thank you, ma'am.
Yes, Sanket. There was a technical issue. I was sending, but network was not there. Okay, so we'll send today totally. Okay. Okay. So in the last class, okay, we have understood. Okay, file handling. Okay, last one program we have to do, but there was no time in the last class, so we shall do it today. Okay. So, and if we complete multi-threading today will be our last class. Okay, so if we don't complete, one more class we'll be having. That's it. And one more thing, Monday and Tuesday, Sunday, Monday, Tuesday, you'll be having holiday. If we didn't complete in case, after Sunday, Monday, Tuesday, Wednesday, I'm gonna take you one class. Okay, Monday and Tuesday for everyone there will be a holiday. Okay, and on Wednesday I might take your class if we didn't complete today. Okay, so we shall start with today's concept. So in our today's concept, we shall concentrate on the buffered input stream and buffered output stream. See, we have two files. Okay, we have, suppose if we have two files, so we have a king file also, we have a queen file also. Yeah. We have a king file also, we have a queen file also. Now, here, from the king file, we're gonna copy whole data into the queen file. From the king file, we shall copy the whole data into the queen file. But suddenly it is will not be able to directly copy. We will not be able to directly copy. Instead, what we have to do, we have to store in one container first. Then we have to check with the application. Then we have to store in one more container. Then the data will be transferred to the file. From the file, king.txt file, then that file, whatever data we have, first it will be taken into buffered input stream. From buffered input stream, whatever the Java file will have, .java file, okay, the control will go there. So everything will be sorted out, like everything, all the code will be checked, and after that, here using buffered output stream, the data will be transferred into queen.txt file. Here, the transferring will happen in bytes. Okay, the transferring will happen. The whole data will be converted to bytes. Then it will be checked with the program. Then it will be again converted to bytes of memory, and then it will be given into the file. Yeah, then it will be given into the file. Okay, so this is about our process of transferring the data from one file to another file. This is the process of transferring the data from one file to another file. Okay, now here. First of all, what is buffer? See guys, buffer is a temporary container. Okay, so buffer is used everywhere. So signal processing also we use buffer. because directly from signal, okay, from your cell phone, suppose you are calling, the signal will go to a nearby satellite, then it will be going into based on satellite, it will be going into whatever the destination. Okay, so directly it will not reach the person. Okay, it will not reach the person. First it will be stored in the buffer, then it will reach the person. Okay, so here in the same way, here if you want to transfer a file, okay, first we have to take the data from that file, then you have to process with the application. From the application you have to take the output, and that too directly you can't store in the file. You have to first store in the buffered output stream, then you have to store in the file. So this is the process will be happening now. Okay, now if you have to understand this, okay, buffered our input stream is used to read the data from the file. Buffered output stream is used to write the data into the file. Okay, so buffer acts as a containers. Okay, buffered input stream reads the data from the file. Buffered output stream gives the data, that is writes the data from the into the file. Okay, so this is about it. And now let us get into our Eclipse. Okay, let us get into our Eclipse, and now we shall start with our last program for file handling. Okay, let it open. Okay, so okay, let it be. Now we shall go to our class, our project first, that is E23. Now here, so what we shall do in under file handling, we shall create one more file, that is buffered input, buffered output, buffered input, buffered output stream, buffered input, buffered output stream. Okay, next what we shall do next is we shall take a main method. Okay, so after taking a main method, next, okay, so next what we shall do here is, okay, next here, okay, here, so we shall have all the code within the try block. Okay, why we will have the code within the try block? Because we might get a checked exception. That is why. So try block. First we have to create an object for file input stream. Okay, see, first from the file. Okay, first we have to read the data into the temporary container. No, we need file input stream. Okay, then after to read the data we need a buffered input stream. Next, to write the data we need a file output stream. From the we need a file output stream. Using file output stream we shall write the data into the file. Okay, but we need a buffered output stream also. Here if you want to read the data from the file, okay, if you want to read the data from the file we need a buffer. If you want to write the data into the file we need a buffer. Okay, now here buffered input stream will work, but your file input stream also will work. File input stream will give the address of the file, and it will help in all the way to copy the data into the buffer. Buffered output stream, it will have the output, and with the file output stream will have the data into the file. Okay, so this is the process happening. And here now let us start creating an object for file input stream. File input stream here. Next, variable fn is equal to new file input stream of path. Take it as C:/ file handling / king.txt. Okay, now here this is the file wherein we have to copy the data. After copying the data, okay, we have to store, okay, that data we have to store in buffered input stream. Now we have to create an object for buffered input stream. Okay, buffered input stream, and here bin is equal to new buffered input stream. Okay, now once again, okay, buffered input stream of, in the constructor we have to write fin. We have to write fin because here in the buffered input stream we will access this file to copy the data and store in the object created in buffer input stream. So we shall import this also. Import java.io.buffered input stream. Okay, next, after that now what we have to do, same thing. If you want to read the complete data, okay, in the R variable we shall start reading bin dot read method. To read the complete data we have to go into a while loop. So before going to while loop we shall take one container. Okay, we'll take one container because the data is in the form of string type. String data is equal to empty container. Next, here now while r not equal to -1, while r not equal to -1, here what we shall do is, whatever the data we access, that we shall convert into character type and we shall store in string. Okay, we shall convert the data into character type and we shall store it in the string. Okay, next. So one time is done, but what we have to do for update part? Update part we have to again reinitialize. Okay, so pin.read method. Now what happens? Whatever the data is present in the king file, okay, everything will be read from the buffered input stream and the data will be stored here. All the data, whatever the data is there, it will be stored here. Okay, we have read all the data here and it is stored in the data variable. Okay, now the data actually stored in object of buffered input stream. Next, after reading the data, okay, for confirmation we have to print the data here. Okay, we have to make sure the data has been read properly. So we are printing the whatever the data has been taken into the data variable. Now we will just print it to make sure data is proper. Okay, now here after that, if the data is proper, we have to tell, okay, that data has been read successfully. Okay, data has been read successfully. And after that, next what we have to do, then we have to go for file output stream. Okay, we have to create an object for file output stream, because through file output stream, from the buffered output stream, we will get the data into the file. Okay, now file output stream. Okay, fout is equal to new file output stream of C: file handling queen.txt. Okay, now here what we shall do is we shall create an object for buffered output stream. Buffered output stream. Buffered output stream bout is equal to new buffered output stream of, okay, fout. Okay, semicolon. Now after that, so what we shall do, suppose if you want to read a string, okay, suppose we want to read a string, what we will do, we will create one for loop using caret method. We will read every character. We will neatly create a for loop and we shall read every character with the help of caret method of index. Okay, so how we shall do is, we shall create one for loop for int I is equal to 0. Okay, I less than data dot length and I plus plus. Okay, now here bout dot write method of here Here we shall go for accessing the data. Data dot caret of index I. Data dot caret of index I, and here what we shall do is, we shall tell the data has been written successfully. Here the data has been read successfully, but here we shall tell that the data has been written successfully. Data has been written successfully. After telling that the data has been written successfully, then we have to close the file. That is vout dot close method. Then here whatever data is there, we have put everything under try block to avoid the exception. I mean the checked exception. Now what we have to do? We have to create a catch block. In the catch block here, to handle everything, okay, so exception E. Okay, now here we shall tell something went wrong. So we can't tell properly what's happening, but in case if it happens, we shall tell something went wrong. Okay, something went wrong. But in case whatever the path of the file which we have mentioned, whatever the path we have mentioned, if it is not correct, okay, we shall tell file not found exception. Okay, next. So if the path of the file is not correct, we shall tell path is incorrect. Okay, so in case the whatever the path of the file we have mentioned, if the path is wrong, okay, we shall tell path is incorrect. Okay, then if what something went wrong, suppose if something goes wrong while executing, okay, that time we have to tell something went wrong. Okay, now currently in the king.txt file, we have to read the data from the king.txt file. We have to read the data. In the king.txt file, we have the data I am the king. Okay, we have to read the data I am the king. From there, the output should be presented in the queen.txt file. From there, the output has to be presented in the queen.txt file. Now, in the queen.txt file, we have here is the queen. Okay, we have the data. Here is the queen. Now, what we have to do is we have to store the data of king to queen. Okay, so now in the king.txt, we have to find that here is the king should be there, and in the queen also here is the king should be there. The data we are just copying from king to queen. Okay, so what we are doing here is we are copying the data of one file into another. Okay, so yes, copying the data of one file to another file is what we have done here. Okay, next, after that, now let us execute. As soon as we execute, whatever data has been read, that has been printed first. That whatever data we have read from the king file, okay, the data which we have read from the king file is I am the king. The data what we have read is there. After that, we have to tell to the user the data has been read successfully. Then, okay, after writing the data into the file, okay, that is into the queen, after writing into the queen, we have to tell the data has been written successfully into the file. The data has been written successfully into the file. We have to tell. Okay, so here we finish our copying one operation, that is copying the data from one file to another file. Okay, so I hope you guys have understood. Everybody got it? And I'll show you the proof here. So we shall go into the file handling. Okay, here we have file handling folder. I will show you in the king file, we have I am the king. In the king file, we have I am the king. And in the queen file also, there is a data I am the king. See here, in the king file also, I am the king is there. In queen file also, same data is there. So now we can tell that successfully we have copied the data of one file into another file. Successfully we copied data of king file into the queen file. Okay, so this is how we shall copy the data from one file to another file. I'm not understanding. Okay, what about others? Have you guys understood? Do you guys understand others? Okay, in real time, everywhere we will use. Everywhere we will use. Suppose you want to copy some data of one file into another file, what you will do? Okay, I'll explain again. Okay, if you want to copy the data of one file into another file through the Java, this is how you will do. Okay, so in the database, suppose if this is connected to database and if you want to copy the data from one file into another file, okay, you will do this. In real time, everywhere we will use. Okay, in real time, everywhere we use to copy the data from one file to another file. Okay, suppose we want to store the data. Okay, suppose we want to store the data and okay, suppose we have ordered pizza online. Now what will happen? Whatever the data we have entered, it will go and store in a file. Okay, and that file will be appearing for preparing that pizza. Okay, now whatever the order was kept, okay, that will be stored as a separate file in there in the history. Okay, so like this we can transfer from one data of one file to another file. Everywhere we can use this. Everywhere it is used. Okay, we have to copy the data from one file to another file. Here a little data is there, but in real time more data you will copy. Okay, so if you want me to explain, fine, I'll explain you guys again. Okay, listen carefully. Okay, see guys, from one file to another file, we have to transfer data. We have to transfer data from one file to another file. Now from king file to king.txt file to, we have to transfer data into queen.txt file. It is directly not possible to transfer. So we take one container called as buffer. We take one container called as buffer. To copy the data from file to buffer, we need a buffer input stream. Okay, and here if you want to store or if you want to write the data into the file, we have buffered output stream. We have buffered output stream. Okay, now here we have buffered input stream and we have buffered output stream. So this buffered output stream will take the output first from the application. Okay, so this is our Java code. Okay, so from the file we shall read the data and store in the buffer input stream. From the buffer input stream, it will get into the code, it will check everything, and actually telling here only everything is getting processed. Then after that, from the Java file, it will go to the buffer output stream. Whatever data is there is processed accordingly to this. Okay, so buffered output stream, from the buffered output stream, the data will go and store in the queen.txt. Yes, you guys got a link? Only one is sufficient for all operation. Each data needs separate code. No, it doesn't need separate code. Why it needs separate code? Whatever data is there, one time we will read. Okay, so if we want to read complete data, obviously we will read here. What we are doing here? Here we are reading everything. String can contain enormous amount of data. So that is why we have taken string. How much ever data we want, we can contain here. We can contain, we can read, and we can write here. In number of data we can write. Okay, there is no limit. Okay, programmer. Okay, fine. Have you guys understood the logic here? Did you guys get the logic here? Logic behind this? Have you guys understood this? Understand? Okay, fine. We shall go to program. Okay. Okay, fine. Okay, we shall go to a program here. Now, in the program, what we have done is, see, we have to read the data from the file, right? We have to read the data from the file. From which file we will read? So we have created an object for file input stream. We have created an object for file input stream. We have mentioned the path. Now there is an object of file input stream. Now in the file input stream, in the king.txt file, there is a data called as I am the king. Now we have to transfer that to file output stream. We have to transfer this to this file. We have to transfer that to this file. Now, how can we do it? Directly from this file to this file, we can't store the data. From this file to this file, we can't store the data. Instead, what we can do, we have to take a temporary containers. We have to take a temporary containers. So temporary containers are called as buffers. So buffered input stream is used to read the data from the file and store in the object. Buffered input stream is used to read the data from the file and store in bin. So from the bin, using read method, we are reading data one by one and storing in the string type data. Okay, string type string type variable we are storing. After storing inside the variable data, we are printing the data. So after printing, we got here that is I am the king. In the data we got I am the king. After that, we are getting data has been read successfully. Why? Because we have read the data completely. So we'll get the data has been read successfully. Now after the data has been read, we have read the data. Okay. Now we have to transfer the data to the queen.txt, and we have to copy the data from the king to queen. Now that is why to take the input only, we have created a file output stream. We have created a file output stream. Now here, so buffered output stream BOUT is equal to here. Why we have created buffered output stream? Because we have to first read the data from the king.txt. This is the logic written. Okay, this is the logic. So I have mentioned here this file. No, this file. Okay, based on this logic only, everything will be stored in the BOUT, that is in the buffered output stream, and then it will be stored in the queen file. Then it will be stored in a queen file. Okay. Suppose if we get any error in the path, which we will get file not found exception. Okay, I mean we'll be solving file not found exception, and if we get any other errors in case, you will get a exception. We'll get a exception. Okay, so if you run the data from the king will be copied. Okay, king will be copied into one string type variable. The copied data is I am the king. Now for confirmation, we will print the data and we will tell the data has been read successfully. After that, now we shall tell the data has been written successfully because the data has been completely copied here. To the buffered output stream, the data has been completely copied. So that is why here we will tell data has been written successfully, and we will close the file. We will close the file. For example, if you take okay, you will be watching your phone now, guys. You will be watching your phone. Okay. Now, suppose if you open YouTube Shorts. Suppose if you open YouTube Shorts, you'll be having a phone, obviously, and suppose. Okay, so suppose if you're watching YouTube Shorts. Okay, now assume you're on YouTube. Okay, you're watching YouTube Shorts. Now, see guys, listen carefully. Okay, suppose in a YouTube you're watching something and your data is not there. Data was there earlier, but now data is not there. But still, whatever the shorts you'll be watching here, okay, whatever the short videos you'll be watching here, currently it will be there. Okay, data was on, but now data is not there. So if you go forward, you will not get it. If you go forward, you'll not get it. But after data, check if you want to. Okay, after data, go back to previous videos. That will be stored. It will be stored and then it will be shown to you. Why? Because directly from the signal directly it can't show you. It has to store somewhere. It has to store in your phone buffer memory. Then only it can show it in your phone application. Okay, in your YouTube application. So this is where we use buffer, and usually we use everywhere. Okay, we use everywhere. Okay, so this is your program. So this is your program to copy the data from one file. Okay, work on the logic and write the data into another file. Okay, so I hope you guys have understood. Everybody understood? Okay, I will take. Guys, did you understand the program? Let me know, be quick. The file not found exception, what is there? If you give the wrong path of the file, okay? If you give wrong path of the file, queens.txt, there is no file called as queens.txt. Okay. Now we shall copy it from the file. Okay. Here, if you don't want it, here from this file we will copy. There is no kings file, kings.txt. Now if you run the code, we will get an exception, but that exception is handled here. Okay. You will get the output path is incorrect. Okay, so you're getting the output path is incorrect. Here we are solving the file not found exception. We are not getting exception here. It is not visible in the output, but we are solving it. We are doing exception handling. Okay, exception handling we are doing. Okay, that is why we are not getting any exception in the output. Okay, why caret method is used? See guys, you have totally forgot string. Okay, suppose I have the data. Okay, I have the data string yes is equal to I am the king. Now what we have to do? Using a character 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now what you guys will do to access every character? Now you guys tell me. What you guys will do to access every character of string? Which method you will use? Suppose you want to print I. System.out.println of s dot char out of 0. Now what output you will get here? Yes, tell me what output you will get here? Caret of 0. That is I. Yes, got it. Yes, that is I. So like that we have taken a full for loop. See, in the while loop, we have understood that we are reading the data, and meanwhile we are converting that integer, that is ASCII values, into the characters, and we are storing in string. Okay, we are doing concatenation here. Then here we are accessing every data of that string. Okay, that data, whatever it is there, using write method, we are writing that into the file. Using write method, whatever the data has been accessed now, we are writing that into the file with the bout. Okay, so into the buffer output data will store, and then data will go and store in the win.txt. Okay, so I hope you guys are very clear now. Yes, I'm using loop because we want to access, no, we want to access complete data, so that is why we are using loop. Everybody understood? Let me know. Okay guys, fine. Okay, so next, okay, so I didn't send you programs, right? That is why you didn't practice and you are getting disturbed. No problem, you go through the programs, you will get it very clearly. Okay, okay, so next what we shall do is we shall get into our multi-threading concept. Okay, so now let us get into our multi-threading concept. This is the last concept for us. Okay, and so here, okay, let us have the concept of multi-threading here. Okay, now here, first of all, thread means, okay, thread means it is an independent part of a program. Thread means it is a independent part of a program is called as thread. Okay, thread is an independent part of a same program which will get its own stack memory for execution, and it will get its CPU timing. It will get its CPU timing, okay, for execution. Now what is thread? See guys, suppose if you take one app, okay, suppose if you take one app, okay, in that app multiple processes will be there. Okay, multiple processes will be there, and in that process multiple threads will be there. Multiple threads will be there. Suppose if you take application, okay, that application will have so much memory stack area, and it will have its own CPU timing. And here every in one application you will have more processes going on. Okay, in one application you'll have more processes going on, and for that process to do individually we have to go for threads. Okay, okay, so first let us understand what is a multitasking. Okay, multitasking means what? Multitasking means doing more tasks at the same time. Doing more tasks at the same time. Doing more tasks at the same time is called as multitasking. Okay. Suppose you are listening to the class now. You might be thinking about holiday. You might be thinking about holiday. You might be thinking about assessment, which I'll be giving at the last. Okay. You might be listening to class. Okay. You might be listening to class, and you might be checking your mobile. If you're watching, you might be checking your mobile, and you might open your eyes and just sleep like that, understanding nothing from the class, and you'll be observing your environment. These are the things you can do. Okay. These are the things you can do. Here you should not do. Okay. But here, these things you should not do. Only listening to the class you have to do. Okay. So here, this is called as multitasking. Multitasking. This multitasking is divided into two types. Multitasking is divided into two types. Okay. So the first one is process based multitasking. Next is thread based multitasking. Okay. So process based means what, and thread based means what? See, process based multitasking means, okay, doing multiple tasks simultaneously where the task has a separate process like class. There will be no dependency between each tasks. Okay. So here, okay. So here, now what we can do is, so see, for example, for the process based is using string builder. What are you asking, man? Okay, so here, if you want to get to know about process based, see, I am on the Chrome. Okay. Yes. Yes, we have studied that. Yes, in string builder we have studied string buffer is safe and string builder is not safe. Okay. Yes, very good. You have remembered. Good. So here, to understand the process based multitasking, see here, currently I am on your class. Okay, I mean in your class now. Now I'm in class. Now I can go to YouTube. I can go to Notepad. Okay. I can go to Eclipse. Okay, I can go to Eclipse. I can go to Paint. Okay, and I can go to this File Explorer. Okay, so like this, in one application, in one platform, here we have so many processes going on. Okay, see, this Notepad is one process. Okay, in that multiple threads are running simultaneously. Eclipse is one process. Okay, it's one process or a program wherein multiple threads are running simultaneously. And here, no, this Paint is also one process. Okay, now this is also operator level. Okay, operator level multitasking. Okay, so this is about your process based multitasking. This is not that much important because we will be studying only about thread based. This is not required actually. Okay, just for your information. So now let us understand the thread based multitasking. Thread based means, so as I told you in the last class when I was teaching a string builder, okay, suppose you have a 10k lines of code, you want to run everything. Okay, now if the first 5k lines, okay, if the first 5k lines is not dependent on the second 5k lines, if the first 5k lines is not dependent on the second 5k lines, we can allocate one thread to this 5k lines and we can allocate one more thread to this 5k lines. So parallelly they both will execute. Parallelly they both will execute at the same time. So we have reduced, suppose here we are taking 2 hours or 2 hours, suppose, or 1.5 or 2 hours if it is taking. Now 4 hours not required, just in 2 hours, 1 hour, parallelly they will execute both. So like this here. Okay, here we will do the task very soon. Okay, so with the thread working, okay, we'll do the task very soon. So here comes our thread based multitasking. Okay, so you should know that You should know that thread means it's a independent part of one program. Okay, it will have one own stack memory, and it will have its own CPU timings for execution. CPU timings for execution. Okay, and threads are used for multitasking. Threads are used for multitasking. Okay, now suppose you want to do one task, you can assign thread to that. The task will be done. But suppose multiple tasks at the same time you want to do, thread 1, thread 2 you'll assign, thread 3 you'll assign, thread 4 you'll assign. So one task you want to do, but you're allocating multiple threads. One task you want to do, but you're allocating multiple threads to do that task simultaneously. And this is what we call it as multitasking. Multitasking. Okay. Multiple threads doing a task simultaneously is called as multi-threading. Multitask means obviously it is under your process based and thread based, and multiple threads are working on one process. Okay, multiple threads working on one process simultaneously is called as multi-threading. So multiple threads will be working on. It is called as multi-threading. Okay, now we have to be very careful in creation of threads. Okay, we have to understand here how to create a thread, how to handle them, how to make it work properly. If we know, we can do wonders actually. Okay, now we have to know that creating a thread is very costly. It's very costly. You should not create unwanted threads. Okay, so here why creating the threads are costly? Because see, in memory, if you're taking, okay, for the threads only, some part of memory is taken. Some part of memory is taken for threads. Some part of memory is taken for executing threads. And if you are allocating one more thread, okay, the whole process will crash. It might go slow and it might crash also. So that is why we should not create unwanted threads. Okay. See, the threads will have CPU timings also, and it will have one stack memory also. If you are introducing one anonymous thread, okay, obviously it will crash. So that is why unwanted thread should be totally avoided. Okay, unwanted thread should be totally avoided. Okay, now you know that who calls main method for execution? Who calls main method for executing? Yes, JVM. JVM calls main method. Fine. Now when JVM calls main method, okay, that means when JVM starts the execution, by default there will be 3 threads created. By default, there are 3 threads created. When JVM calls main method, that means when JVM starts the execution. When JVM starts the execution, 3 threads will be created by default. Okay, when JVM starts the execution, 3 threads will be created by default. First one is main thread. Okay, Second one is garbage collector. Third one is thread scheduler. Okay, whenever JVM starts the execution, there are 3 threads created: main thread, garbage collector, thread scheduler. Okay, let me show you something. Okay, and you should know that by default all the programs in Java will be executed in main method. You should know this. Okay, you should remember this, that all the programs by default in Java will be executed by main thread only. So I will show you one output. If you have observed, you will get to know that. Okay, let us create one package. I will show you here. So we shall create one package naming. Okay, multi-threading. Under multi-threading, now we shall create one class. Okay, we shall create one class called as multi-thread. Now we have created one class called as multi-thread. Now without a main method, it is not possible. Okay, it is not possible to execute. Now I will execute the code. Now you can see the output here. Let us run the code here. Okay, currently we have nothing. We shall print something. Okay, now if you execute, we get high. Execute now, we get high. But in case if we remove the main method, okay, in case if you remove the main method and if you run the code, remove the main method and if you run the code, okay, so see the carefully see the output. Carefully see the output. Error, main method not found. Okay, we got a error. Okay, now, so usually what you'll get error in the thread main. Okay, now here main method not found. You will have to start executing from there. Suppose if I go for a print statement and I write nothing here. So print will not accept nothing. Print will not accept nothing. So if we execute now, okay, if you run the code, so see the output carefully now. Exception in thread main. Exception in thread main. Okay, what is main? Main is a thread. What is main? Main is a thread. It has one task, it is doing that. So we have suppose any exception, any error happens here during the runtime while executing, you will get there is a exception in thread main. Okay, you will get error only, but actually the thread's exception is happening. Okay, now this is why main method is necessary for all execution and you should not do errors in it. Okay, now what we shall do is very simple. Okay, so let's take a new file. So here, okay, so now what we shall do is, we know by default all the programs will execute only if Java has a main method. Okay, if the Java program has a main method, then only it will execute. This is by default there. Okay, and now let us see how the thread is created. How the thread is created. See, this is about a thread, right? Now, how the thread is created, now we have to know. Okay, how the thread is created, we have to know. See, guys, there are two ways of creating a thread. One way is by extending thread class. By extending thread class. This is one way. By extending thread class, you can create a thread, or by implementing a runnable interface. By implementing runnable interface, we shall create an object for thread. Okay, we can create an object for thread in two ways: by extending thread class and next by implementing runnable interface. By extending thread class and by implementing a runnable interface. Okay, now before seeing how to create a thread, now we shall understand the life cycle of thread. Okay, here first only we will understand the life cycle of thread. See, suppose if there is a baby, okay, the human baby, first it will be born, next it will try to crawl. I mean, it will crawl actually. It will crawl. That means it will try to run. Next it will run. Okay, run actually. Then while running, it might go into waiting stage or it might go into sleeping stage. Okay, then after that it will directly go, and I mean, obviously every human should die, every living thing should die one day, so it will die, terminate. In the same way, the thread is there. Okay, in the same way, the thread is there. Thread will be born with the help of new keyword, and thread will be able to go in a runnable stage. Okay, in a runnable stage. It is not running still. And here in this stage, it will be running. Okay, and after that, while it gets tired or some error happened, it will go into wait stage or it will go into sleep stage. Wait stage or sleep stage. But in case while waiting, it got woke up again and it want to run again. So what it will do, it will go to crawling stage, then it will go to run stage, and then it will be terminated properly. terminated properly. Okay, so that it will die properly. It will die properly. Okay, after waiting. So directly from sleep it can die, or when waiting or for sleeping it can go back to crawling stage. Again it can run from the first properly and it can terminate properly. So this is the life cycle of a thread. And here we have to, for creating a thread, we have to use a new keyword. And those creating a thread is of two types, by extending thread class and by implementing runnable interface. This runnable, okay, so currently that thread is in runnable stage. That is trying to run. It is in runnable stage. This is with the help of a keyword called as start method. I mean, this because of the start method, this will happen. To create a thread, we need new keyword. To make the thread get ready to run, we need a start method. And for the thread to actually run, we need a run method. For the thread to actually run, we need a run method. Okay. While running, if the thread goes into sleep mode, we have sleep method. If it goes into wait mode, if we have wait method. Okay. Suppose if the thread we want to stop directly, we can go for stop method. We want to terminate there and then and there itself. Okay. So this is the life cycle of thread. Okay. And next here. So we have studied there are two types of creating an object for thread. Okay. That means there are two types of creating a thread. Now first one, let us learn. Okay. Now let us learn the first one, that is by extending thread class. By extending thread class. Okay. Now what we shall do here, we have to create one thread. Okay. So what thread we shall create here is okay. So here we shall create. We have a main method here. Fine. Now what we shall do is, let us create one thread. Okay. So class, the name of the thread will be my thread. The name of the thread will be my thread, and this my thread will extend the thread class. Will extend the thread class from java.lang package. Suppose you want to make one class as an exception. Okay, that means suppose you want to make a class as an exception class, what you will do? You will extend the exception. But if you want to make a class as a thread, okay, you have to extend thread. Okay. Now after that, see guys, if you want to allocate one task for the thread, you can do it only one way. Okay, you can do that in only one way. The way is to override run method or to use the run method. Okay, so within the run method only we can give the task. So here this is our run method. Okay, this is the run method. In the run method only, inside run method only, we have to do the task. Okay, we have to give the task for a thread, means it is possible only inside the run method. Okay, so now here, so what we shall do is parallelly we will give task for both main thread and this thread. Main is also one thread, right? And my thread is also one thread, right? Now what we shall do, simultaneously we want the thread to execute. We will not give any timings, we will not give any waiting stage. Okay, but we want the two threads to be executed properly. Okay, so guys, so tell me, suppose you went to a movie. First audio is coming, then video is coming. How it will be? Will you be able to see it properly? First audio will be coming and video will be coming next. Audio and video. Will it be good to watch? No, right? Yes. It will not be good to watch. Obviously, it will not be good to watch. So what we want to get here? Parallelly, both the video as well as audio or music should be played parallelly. Both of them should work. If they are not working properly, then there will be some problem. Okay, to hear and to see. That is why we have to make sure video and the audio or music we should work properly. Okay, now here So here, suppose if you want the task of the main method, okay, let us give the task of the main method wherein you have to print the video, playing video for some times. Okay, now let us take the program. So task is using for loop, we shall print something for 5 times. Okay, so int I is equal to 1, I less than or equal to 5, and I plus plus. Okay, now here. Now, suppose we want to know which thread is currently getting executed. Suppose we want to know whether main thread is getting executed or my thread is getting executed. We have to print the name of the thread. We have to print the name of the thread. So how can we get that name of the thread? So the name of the thread you can get with the thread class dot thread dot current thread dot get name method. Get name method. So using get name method, we shall get the name of the method. So after that, we shall allocate the task to it. We shall allocate the task to it. The task is playing audio. Okay, playing. Okay, here we shall tell playing video. Okay, playing video. So playing video is a task which we have given for main thread. Okay. Now the same task we shall give, but we shall go for playing audio. Okay. So in the run method, suppose if you want to give any task, for the thread, you can give inside run method only. Okay. Keep reminding this. Remember this. Okay. Now thread dot current thread dot get name dot playing video, playing audio. Okay. So now here is a thread. Okay. It is running currently here, but we have to create it, right? We have to create it and we have to make it run. Okay, we have to make it prepared to run. Now what we shall do is we shall go for creating an object for this class. So my thread variable m is equal to new my thread of new argument constructor. Next, we want to make the thread. Okay, new keyword has created a thread. Object is one. Excuse me. So after the object is one, m dot start method. We have to make the thread to start running, and actually it will run here. Actually it will be running here. Okay, using run method. Now what we shall do is we shall start executing the code. Our main aim is video and music should be played parallelly. So what are we getting? This thread name is main. Okay. Now thread name is thread 0. How many other threads we create except main? Okay, main is a inbuilt thread. Now, how many other thread we create instead of main? I mean except main. Okay, here thread 0. You have given no name for the thread. That is why you have got thread 0. For this my thread, you have not given any name. This is just a class name, thread name. You have not allocated any name to the thread. Now, how can we allocate this? How can we allocate the name to the thread? How can we allocate the name to the thread? Very simple. Okay, very simple. So we have to go for printing, giving the name or creating the name, that is thread dot current thread dot set to the name method. Here we can give a name called as Kumar thread. Okay, Kumar thread. Okay, so we don't have to print it. We shall take it directly. Okay, thread dot current thread dot set to the name. We have set to the name already, and here when you're getting the name, you'll get Kumar thread. Okay, any name you can give. You can give your name. Okay, so here you're getting a Kumar thread and main thread. Now it got mixed a bit. Now we have to keep executing until we get a correct output. Okay, so here we have not given any condition properly. Okay, we have not told what time it has to start, what time it has to stop. But here, okay, so what are we seeing here? Playing video and playing audio parallelly we have seen. Playing video and playing audio we have seen it parallelly. So this is our output. Okay, this is our output. So let me take a snap of it. So if you're doing it for the first time, you might not get it. You have to keep executing. When you're doing it for the first time, you might not get it for the first time. You have to keep doing it. Okay, so this is how you will be creating one thread. Okay, and you'll be giving a task for it, and main thread and this thread parallelly, this is how they will execute. Now if you see the output here, okay, playing video, playing audio, video, audio. So if you can see, parallelly both are getting executed. Parallelly both are getting executed. Okay, so this is about your thread, how to create a thread and how to make two threads parallelly execute, two threads parallelly execute. Okay, and here we have seen how to create a thread using extending a thread class. How to create a thread by extending thread class we have seen here. By extending thread class we have seen here. Next, how to create a thread by implementing a interface. Now we will see. Okay, by implementing okay, runnable interface. By implementing runnable interface. So implements runnable interface. Okay, now here what we are doing, we are making this my thread as a thread. We are making this my thread class as a thread by implementing a runnable interface. Okay, so there is one problem here. See, one problem is that, see, this runnable is there. No, this is an interface. Okay, listen carefully. In the second way of creating a thread, by extending thread class done. Now by implementing runnable interface, we have one problem. See, we shall take a run method from the thread class. No, thread is a class which is inheriting runnable interface. It's inheriting runnable interface. Thread is a class which is inheriting runnable interface. That is why from the runnable only this run method was there. In the thread, the inbuilt method is start and stop. The thread inbuilt is start and stop. But this run method which we are using by extending thread, no, it is actually from the runnable interface. It is actually from runnable interface. Now what we are doing is, we are directly implementing a class to runnable interface. Are you guys getting? My thread class. Directly we are implementing to runnable interface. So two ways are there, by extending thread or by implementing runnable interface. Now what we are doing is, now we will see how to implement using runnable interface. Okay, now, so here same thing. So by implementing runnable interface, no change of code here. Now what you have to change here is, see, start method is present in thread. Okay, but here we don't have the thread. So what we have to do here is, we have to create an object for thread here. Thread t is equal to, okay, new thread of. So you have to pass this variable m inside the thread. Okay, you have to pass this variable, my thread variable m, inside the thread constructor. You have to pass inside the thread constructor. Inside the thread constructor you have to pass. Okay, now from the thread t dot start method you can implement. T dot start method you can easily implement. When you implement the runnable interface, we don't have start method in the runnable interface. We have start method in the thread. So that is why we are creating a thread. We are creating a thread, and in the constructor we are passing the reference of that class my thread. Reference of the class my thread, that is m. Okay. Now with the help of this reference variable t dot start method, easily we can start the thread. Okay. So this is how, using a runnable interface, you can execute the code. Okay, let us see the output. Okay, still same output we are getting. That means our code is working. So by extending thread class and by implementing runnable interface, this is how we can do it. Just a minute. Let us take a snap of this. Just a minute. Let us take a snap of this. Okay. So here, okay, yeah. So this is how you can create an object for a thread. Okay, you can create a thread using two ways, by extending a thread, and second one is implementing runnable interface. I hope you guys are, and what is this? Implementation part. Okay. So look carefully. So second way of creating a thread is by implementing runnable interface. If you implement a class to runnable interface, still you will create a thread. Now here we want one run method to give the task. Obviously here run method is from runnable interface only. So for the thread we have created one task using runnable method. Run method. Now you should know that if you want to start the thread, suppose if you want to make the thread start running for thread born, okay, here the thread is born because of new keyword, the thread is born because of new keyword, the thread is born. But thread should start crawling, right? Thread should start crawling. That means thread should start crawling. That means it should start executing. Okay, it should get prepared for execution. So what we have to do here, when it wants to prepare for execution, we have to start it. For the execution. So this start method, which we want to get it, it is from the thread class. It is not in runnable interface. Okay, this start method is in thread class. It is not in this runnable interface, which is implementing runnable. No, it is not there in the runnable interface. It is not there. So what we have to do, we have to create one thread class. We have to pass this variable into this thread, and we have to go for the start method to start the execution. Okay, to make the execution start. Okay, we have to go for start method. Okay, so this is about our implementing runnable interface. Yes, everybody understood? You guys got it? Everybody? Okay. Guys, if you are not understanding, you can let me know. Understood? Okay. Preet is understood means everybody has understood. Yes, got it. Good. Okay. See guys, if you are not understanding, you can let me know. Okay. Okay. I hope you have understood. Okay. Next. So guys, have you booked movie tickets anytime? Have you guys booked movie tickets anytime? Yes. Okay. So when you're booking a movie ticket, okay guys, fine. So when you're booking a movie ticket, okay, suppose you go into one specific movie, okay, you will go to one specific movie. There you will see the timings and you want to choose seats. Okay, you want to choose the seats. So balcony, this some seats are there. Okay, I'm just writing it randomly. Okay, now here, suppose if the seats are booked already. Suppose if the seats are booked already. So the seats which are booked appears in gray color. Seats which are booked appears in gray color. Okay. Yes, it will appear in gray color. Whatever the seats are booked, no, they will be appearing gray color. Now, which seat you have to book here? You have to book the remaining seats which are available. So what's happening here is, the application is allocating one thread. Okay, it is allocating one thread between the time. Okay, between the time, suppose 2 p.m. to 4 p.m. 2 p.m. to 4 p.m. 2 hours there is a movie. Assume now here from 2 p.m. to 4 p.m. this thread will lock this seat object. Okay, and this is also locked by one more thread. Like that, the threads are locking these objects. How much time? Only within this time. Okay, within this time it is locking. So that is why in a specific movie, if you see some seats, they're already booked, you can't do anything for it. If you want to book, you can go for the remaining seats. Okay, now here this way of not allowing user, okay, this way of not allowing other user to enter, okay, or disturb other objects is called as synchronization. Okay, synchronization. Okay, this is achieved using synchronization. Okay, so actually telling here we have a race condition. Okay, race condition means, okay, So multiple threads will be there. Okay, so many people will be there. Multiple threads. See, one people if you take, we consider as a one thread. Okay, so multiple thread trying to access the same object. Okay, suppose like this. One object is accessing this, okay, and some more objects are trying to access the same object. Okay, so if multiple threads trying to access the same object at the same time, then we call it as a race condition. Race condition. Okay, and race condition always leads to inconsistent data. So if the race condition was there, see guys, I will tell you what problem will happen here. Suppose this seat has been booked by many people. If the locking was not there, if synchronization was not there, this seat would have been booked by many people within the same time. So now here problem occurs. So one person, fine, but many people, if they are booking the same seat at the same time, then a race condition occurs, which means multiple threads, okay, multiple threads trying to access the same object. Multiple threads trying to access the same object is called as race condition. Okay. So here, race condition always leads to inconsistent data. So how inconsistent data? None of them will get a seat. The seat is one. How many people will get it? So there will be a quarrel and none of them will be beneficial of it. Okay. Now, to overcome this race condition, we go for thread synchronization. Using thread synchronization, we shall lock the booked object. Okay, we shall apply one lock on that object. Okay, thread synchronization is executing the threads in the sequential order. Where one thread will execute only one object. Okay, at a time. At one time, one thread will execute, okay, one object at a time. Suppose one more thread has to execute that object, it has to wait till object has reached the exit part. Okay, it's like, okay, suppose you want the same seat. Now what you have to do? Already one person is acting on it. That means one person has already booked it. But if you are trying to book it, it is not possible. You have to wait till 4 p.m. If you want the same seat, you have to wait till 4 p.m. If you want to wait till 4 p.m., obviously there will be late. So if you want to book the same seat, you have to wait till 4 p.m. So this is what's happening here. So thread synchronization means it's executing the threads in a sequential order, one after the other. Okay, where one thread will execute only one object and next one more thread we want to execute means it has to wait until the thread which is executing will leave. Okay, it's like, okay, let me explain you. Suppose you are going into an ATM. Okay, suppose you want to withdraw some money, you're going for an ATM. There is one ATM machine and there will be a watchman, okay, with a gun. Okay, now, so people in the line, suppose there is some thing going on, so people are lining for the withdrawing money. Okay, now the person who came first, now he will go inside and only one person is allowed at a time. Until he withdraws cash and come out. This watchman will not allow another person to enter. So here we can tell watchman is a synchronized keyword. Okay, here watchman is a synchronized keyword. Why? Because he is not allowing more than one element or more than one thread to enter the object. So he is allowing only one thread to enter the ATM object, and after the object gets out of the ATM object, then he is sending one more object. So this is what we call it as a thread synchronization. Okay, so thread synchronization means executing the threads in a sequential order. Where one thread will execute only after another thread completes the execution. These threads will execute only after this thread has got executed completely. Okay, now this thread synchronization also you can do in two types. Two types of thread synchronization you can do. Okay, now let us see what are those. Okay, two types of thread synchronization you can do. So that is, okay, you can do thread synchronization you can do, okay, in two types. That is That is using synchronized blocks, or a block is also there. First, by using synchronized methods. By using synchronized methods. Second, by using synchronized blocks. By using synchronized blocks. Okay. Now, thread synchronization can be done using synchronized block methods or synchronized blocks. Okay. Now, let us see how it is done. Okay. Let us see one example for data inconsistency or data inconvenience by the BookMyShow application. Non-gray color. Okay. So here let us go to an application, that is BookMyShow application. BookMyShow. Here is our application. So what we shall do is we shall go for one driver called as BookMyShow driver class. Okay, we shall keep it as it is here. Okay, now let us create one more class here, because here we have to execute with the main method. Now let it be. Now we shall create one more class here, because we'll be doing everything in the same file. Now we shall create one more class. The class name is BookMyShow. This is one normal class. Okay, now in the BookMyShow, okay, in the BookMyShow, first let us take the number of seats which are there in the theater. Now for our reference, we shall take minimum 10 seats. Okay, we shall take only 10 seats for understanding the program properly. Okay, so int total seats is equal to 10. Total seats are total seats, there are 10. Now what we have to do? See, we have to do a task. The task is what? Booking the seat. The task is booking the seat. Now, if you want to book a seat, okay, if you want to book a seat, we have to go for a method. That means one function. Okay, so we shall go for public void book seat method. Okay, wherein we shall take input from user, that is the seat method. Okay, the seat method. If see, what we have to do here is, if already booked seats is 10. Okay, see guys, now tell me, if all seats are booked, is it possible to book the seats? If 10 out of 10 is booked, is it possible to book the seats? Obviously no. Okay, but if the seats are booked 5, but you're trying to book 6 seats, there are 6 seats wanted to book, but there are already 5 booked and 4 left. 5 booked and 5 left. Now, is it possible to book 6 seats again? Is it possible to book 6 seats again? Only 5 we can book. So here we have to write one condition. Whatever user gives, okay, whatever user gives, that seat, okay, whatever the user tells the seat, that seats should be less than or equals to the total seats. That seat should be less than or equal to total seat. We have to tell user that this many seats you have booked and these are the remaining seats, because people will not believe here. In Java, currently we are doing in Java, we don't have any front end here. We don't have any front end to show the number of seats. Okay, to show the seats, we don't have front end. Instead, what we will do, we will write using code. Okay, so using code, if we write here, now we will tell, we shall first write the seat variable. We will tell these many seats are booked successfully. 1 second guys, just a minute. Background voice is coming, just a minute. Okay, guys, there was some background noise. Excuse me. Okay. Okay. So here, now, yes. So what we were doing, we were having number of seats here, and we were having a condition. Okay, we are having a condition that the total seats we have. Okay, it should be equal to. I mean, whatever the seats are, the total seat is 10, and whatever user books the seats, it should be equal to 10 or less than 10. Whatever user books, it should be equal to total seat or less than total seat. Okay, now here, first we have to show user. Okay, if this condition is true only, control is coming here. Okay, if the condition is true only, control is coming here, and it will tell that many seats are booked. Okay, that many seats are booked successfully. Okay, that many seats are booked successfully. So after booking the seats, now you guys tell me, after booking the seats, will the number of seats increase or will the number of available seats decreases? What will happen? Will the number of seats increase, available seats, or yes, it will decrease? Yes, it will decrease. Now what we have to do here? We have to do subtraction. Here we have to do subtraction. Okay, now here, now within this if block, we shall do one subtraction, that is total seat is equal to total seat minus seat variable. Okay, total seat is equal to total seat minus seat variable. Now we have to reduce the number of seats which are being booked. Then we have to show the user that remaining seats are this much. We have to show the user that remaining seats are, okay, so we shall go for total seats. Okay, so we shall show that remaining seats are this much. Okay, now here, if the number of seats whatever user has been booked, if it is less than or equal to total seat, then here we will book the seat and we will reduce the values and we shall tell these are the remaining seats. But if the seats are more than, that means if this condition is wrong, it means that the number of seats which user has given is more. So if this condition is not matching, okay, if this condition is not matching, in the else part we will tell sorry, seats are not available. Okay, so this one sentence we will tell, and as a proof we will show how many remaining seats are there. Okay, as a proof to the user we shall show how many remaining seats are there. Okay, next. Here, so here we have a book my show and here we have a logic for that. Now if I don't prefix a synchronized keyword, multiple threads will act upon this object and it will ruin it. Okay, so as a thread, we will create two thread objects. Okay, as a thread we shall create two thread objects we shall create. Okay, now how we shall create two thread objects here? How can we create two thread objects? Very simple. Here we will create one person, one thread. See, obviously persons or people will be acting. So here we shall go and create one class, person one class. And if you want to make this as a thread, okay, extends thread class. And here, see, the person should book the seat where? In the book my show object. The person should book seat. So we shall mention the object, that is book my show, with the reference PMS, because the person one should, or the thread one should book the seat in the same object only. So there is has a relationship going on. There is a relationship going on here. So we are mentioning the book object inside the person one. Okay. Now we have mentioned the book object with the reference. Next. Now let us create one constructor for this. That is person one. Okay. And here person one of. In the arguments we shall go for bookmyshow variable PMS. So we shall initialize this dot bookmyshow is equal to bookmyshow variable. Now here, okay, here for this person one, this is a thread. No, we have to give a task. Now tell me which method we have to use. Okay, which method we have to use? Which decrement operator we can use? Yes, which method we have to use for assigning task for a thread? What is the method name to assign the task for a thread? Method name. Yes, tell me. Just now we have used. Hey, what is this? When we create a thread, we have to assign one task. Where we are assigning? See the program here. The previous program, see where we are assigning the task. Where we are assigning the task for a thread, for a user-defined thread. Where we are assigning? Inside run method. We need a run method. Okay, we need a run method. No. Implementation extending is just a ways of creating a thread. Okay, but if you want to allocate task for a thread, I don't know what you guys are understanding. Guys, don't get confused. See, implementing and extending, those are two ways of creating threads. But we have to give a task for a thread means you have to go for a run method. You have to go for run method. Using run method only, we will be able to give or provide a task for a thread. Okay. Same here also. If you want, this is a person one thread. This is a person one thread. Now what we have to do? Now we have to give one task for this. So we have to override this run method. Okay, we have to override this run method. And what task we can give here? What task we can give here? Now here. Okay. Now here we can give a task that is to book the seat. While booking a seat, we shall take a variable BMS dot book seat. So we can tell minimum 6 seats will book. Okay. So that's all about this class person one. Okay. Class thread person one. Next we shall create one more person 2, and here we shall change person 2, and here we shall give 4 seats. Okay, 4 seats to book. Okay. Now person 1 over, person 2 over. Next we shall go for creating object for this bookmyshow. Okay, inside the driver. So we shall create bookmyshow object. Bookmyshow DMS is equal to new bookmyshow of no argument constructed. Bookmyshow of no argument constructed. Okay. See, these are threads. Okay, this is a bookmyshow object class. Okay, main object class. Now here, this person 2, person 1 are threads. Okay, so person 1 and person 2 are threads. Person 1 and person 2 are threads. We have to create an object. We have given a task for them, right? We have given a task for them, but here we have to create an object for that to initialize the threads. Okay, so how we shall create? Person 1 even is equal to new person 1 of no argument constructor. But here, since in the constructor we have passed the reference variable BMS, will be there. Okay. Next we will start the execution with the help of P1 dot start method. Same goes for P2 also. Okay. Same goes for thread person 2 also. So just we have to take person 2 variable. Here also variable name we can change P2. Next P2. Now P2 dot start. Okay. Now let me see the output. Okay. Let us see the output here. So in the output here, see, listen carefully. See the output carefully. What are we getting? 6 seats are booked. See the output carefully. 6 seats are booked successfully. Remaining are 4. 4 seats are booked successfully. Remaining are 0. Now, can you see here? Is the output proper, everyone? Are you guys getting the output properly? Is the output proper? So one thread is booking 6 seats, remaining are 4. One more thread is booking the seats, 4 seats are booked successfully, remaining are 0 because we had 10 seats. Now see the magic here. I'll just execute the code again. I'll keep executing. Now, are you seeing the irregular output here? Is this a proper output? 6 are booked successfully, 4 are booked successfully, remaining are 0, remaining are 4. What is this? This is not a proper output. This is not a proper output. To get a proper output, so what's happening here? Threads are not working at a time. Okay, I mean they're interchanging, they're mixing and working. They're mixing and working. Now what we have to do here is we have to apply a lock on them. Okay, we have to apply a lock on them. Okay, so how we can apply a lock? We can apply a lock by prefixing. Okay, by prefixing synchronized to this book seat method. By prefixing synchronized to this book seat method. Synchronized to this book seat method, we shall achieve this lock. Now output will not change. Okay, now output will not change. See, I'll keep executing. Output will not change. Okay, output will not change. See, n number of times I'm executing, output is not changing. Okay, yes, we have to apply synchronization. So this is the power of synchronization, where it will take only one object while executing. Until the object execution complete, it will not allow another object to execute. So one object executed completely, then one more object went and executed completely on this book seat method of the bookmaestro object. Now here, now we shall make one thread wait. Okay, we shall make one thread wait and we shall make the thread execute. We shall make one thread sleep actually. Waiting, it will go to infinite time. We shall make a thread sleep. Okay, we shall make a thread sleep. Now, how can we make a thread sleep? So very simple. So whichever thread we want to make the thread sleep, we can make the thread sleep. So what we are doing now? We will be okay, changing the number of seats here. Suppose we'll book 5 seats here. Okay. Now we will make this person one thread wait or sleep. Okay. Wait will go to infinite time. So we will go for sleep method. Try of sleep method. So here, so whatever the task we have taken from run method, no, we shall go for a try block. Why we have to go for try? It's because here this waiting, okay, this waiting, which I will be doing now, that waiting will contain a checked exception, that is thread dot sleep method. Okay, so here minimum we shall wait for 1000 milliseconds. 1000 milliseconds, but sleep directly terminated, mama. We are giving time, no. Waiting can go to infinite time if you are not giving proper time. Okay, but sleeping, we are making it to sleep only for some time. Okay, we are making it sleep only for some time. So sleep of 1000 seconds. So 1 second is equal to 1000 milliseconds. 1 second is equal to 1000 milliseconds. And since this is a checked exception, so we are implementing this inside a try block. Since this is a checked exception, we shall write this within the try block. Then we need one catch block. To catch the exception. So we will get here interrupted exception. Here we will get a interrupted exception for sure. Okay, because the thread will be slipping by mistake. If some problem happens, your catch block will catch it, and you shall go for printing the stack trace. Stack trace means you have seen an exception. So tracing of the program from where it started, from where it went. So everything will be visible in a stack trace. So e.print stack trace, it will print the stack trace. Okay, now here what we are doing, we are making the person one wait for 1 second. And person 2 execute. Okay, person 1 will execute after person 2 executes. Listen carefully. Person 1 will execute after person 2 executes. Okay, now person 2 is executing. Person 2 is executing. He will book 5 seats. After booking, now person 2 comes to, after 1 second, person 1 executes. Person 1 will execute 6 seats. Okay, he will try to book 6 seats. Now, if we run the code here, we shall get here 5 seats booked successfully. Person 2 is executing. So person 2, we have 5 seats. Okay, 5 seats are booked successfully here. 5 seats are booked successfully, and person 2 is executing again. So 6 were there. Here we have only 5. So seats are not booked successfully. Try block for person 2, no, because you need to wait for person 1. No, that is what we can make, whatever the person wait. We can apply for person 2 also. That's left to you. I am applying for person 1. We are making the person 1 wait and person 2 execute. Okay. So I am doing politics here. Okay. I am doing politics. I am making person 1 wait and I am allowing person 2. Okay. See, person 1, person 2, usually they will execute. After person 1 executes, see, the reason is, politics not doing here. Okay. The reason is, person 1 usually will execute, then person 2 will execute. We know that. But if you are making one person wait, okay, if you are making one person wait, obviously one more person will execute. If you are applying that lock for person 2, okay, there will be no difference. See, person 1 will execute, and after 1 second, if you execute person 2 also, there will be no difference. But we have to know what's happening. So we are making person 1 wait and we are executing person 2 to understand how the waiting period is happening. So if I execute here, see, there will be 1 second of time delay. Okay, can you see the time delay here by 1 second? Next. Okay, can you see the time delay here? Delaying is there. So person 2 is executing first, 1 second time delay, then person 1 is executing. Seats are not proper. I mean, there are only 5. We are trying to book 6. So remaining are 5. Yes, you guys understood how Book My Show application works in our Java currently? Guys, should you get it, everyone? How it's working? Guys, did you understand how it is working? Okay, I have to ask you guys multiple times. So we might not be able to complete it today. Okay, we shall complete how much ever is possible today. Okay, now, what will happen? Apply for person 2. Yeah, same thing will happen. Person 1 will neatly execute. After 1 second, person 2 will execute. Person 1 will neatly execute. After 1 second, person 2 will execute. Same thing happens. But we are making the person 2 execute first by waiting. I mean, by making the person 1 sleep. Okay, by making person 1 sleep 1 second, we are allowing person 2 to execute. You can apply the sleep method here also. So when you apply for the person 2, person 1 will execute first. Then after 1 second, person 2 also will execute. Okay, so this is what will happen. Clear, Sanket? Okay. So, okay, guys. So let us go for the next one here. Okay. So to understand next concept, we need to be little cautious. Okay. Now, okay. One more thing is there. So here, we were using synchronized. Okay, in Book My Show, here we are using synchronized methods, and I told you can use synchronized blocks also. So now what we will do is this whole code we shall mention. We shall mention inside this whole code. We shall mention inside the synchronized block. Okay, synchronized block. So here in the synchronized block, we shall write this keyword. In the synchronized block, we shall write this keyword. So inside this keyword, okay, currently executing object address will be there. Whatever object is currently executing, it will be accepted, and now whatever data is there, we shall apply that in a synchronized block. See, now you don't have to write synchronization in method also. You can remove it. You don't have to mention it, but I'm not removing because in a method also you can apply. That is way. If I remove, this will be going. So without this also, just with the synchronized block also, you can execute the code. Okay, suppose outside this, now what we'll do is we shall tell good morning. Okay, suppose if this is happening in the morning, we shall tell good morning, or we shall tell hi. Shall tell hi. Okay, now see the output. Now see the output, you'll get hi. This many booked, hi, sorry, not available. This is for one person. For one person, hi, 5 seats are booked successfully, remaining are 5. Next, for one more person who is booking 6 seats, hi, sorry, seats are not available, remaining seats are 5. Hi, sorry, seats are not available, remaining seats are 5. Remaining seats are 5. We can do that. Have a nice day. Okay, we shall implement that here. Shall implement that. Okay, we shall tell have a nice day. Here also we can book for the person who booked. We can tell, we can implement here also. Okay, so now if we execute the code, let us execute the code here. Okay, so one person executed, next one more person. Okay, so what we are getting here is hi, 5 seats are booked successfully, remaining seats are 5. Have a nice day. Okay, next hi, sorry, seats are not available, remaining seats are 5. Have a nice day. Okay, have a nice day. Okay, so this is about our code. Okay, and I hope whatever I taught you now is understood. Okay, next. Okay, one last concept is there. Okay, we shall try to finish today. Okay, one last concept is there. Okay, we will try to finish today. If not possible, we will understand that in a next class. Okay, so here, okay, let me tell you one scenario. Okay, so the scenario is here. Okay, suppose assume there is a plate of food, or assume there is a chicken leg piece. Now there are dogs in the park. Okay, there are some dogs in the park, and they have seen this chicken leg piece. So since they have seen this chicken leg piece, now what they will do? Okay, let me read the dogs here first. So assume this is one dog, okay, which is directly staring at it, and this is also one dog, okay, which is directly staring at this food. Okay, now this dog is holded by one owner of the dog, and this dog is also holded by one owner. Both the dogs saw the food. And now they saw the food. Next thing is they saw each other. Now here they saw each other. Now a fight happens. Surely a fight happens. But these owners are there, no? They will not allow these dogs to fight. These dogs are very eager. So whomever will win, no, they can have a chicken leg piece. Okay, they can have a chicken leg piece. But here, this dog is trying to hurt this dog, and this dog is trying to hurt this dog. So what they're doing? Mutually, they are trying to lock each other. Mutually, this dog is trying to lock this dog, and this dog is trying to lock this dog. So mutually, they are trying to lock each other. They're trying, and they're waiting until the owners leaves the belt. Until the owners leave the belt, they're waiting and they're trying. So this is called as thread deadlock. Okay, this scenario is called as thread deadlock. Thread deadlock means, okay, it's a situation where two threads are waiting. Continuously. Okay, they will be waiting to lock each other objects. Two threads are waiting to lock each other objects to complete the execution. to complete the execution. Okay, and they can wait for infinite time. They can wait for infinite time for locking each other objects to complete the execution. Okay, thread deadlock means two threads. Okay, it's like it's a situation wherein two threads are waiting to lock each other objects. Okay, to complete the execution and wait for infinite time. To complete the execution and to wait for infinite time. Okay, and here this thread deadlock is a problem here. See, two threads are waiting infinite time is what program you will do, right? Suppose this thread is waiting for this thread to lock and this thread is waiting for this thread to lock. It is going for waiting for infinite time. So it is waiting for infinite time. Now, since it is waiting for infinite time, we can't do any work. So we shall break this. So how we can break this? By communication. Okay. So here we shall have a communication called as inter-thread communication. We shall have a communication called as inter-thread communication. The communication is this communication between these two threads. Okay, communication between these two threads is called as inter-thread communication. Communication between these two threads is called as inter-thread communication. Okay, then this inter-thread communication is achieved with the wait method also. Okay, if you give time. Okay, with the notify method and with the notify all method. Okay, so how with the wait, how with notify all, we shall see in a next class. How the thread deadlock happens, we shall see in our last class. Okay, yes, 4 minutes are there. It is not possible to complete today, so we shall have one more class. I will tell you when I will take the class. So normal class I might take on Wednesday. If I'm not taking on Sunday, so you have 3 days leave. Okay, you will have 3 days leave. Sunday, Monday, Tuesday. I am not taking tomorrow, so you're free. Monday, Tuesday, any one day I might take, and you can have a complete leave from there. Okay, but if I'm not taking on Monday and Tuesday, surely on Wednesday I will take one class for you. That will be your last class. Okay, that will be your last class. Okay, so yes, post on Qt. Yes, I will do it. I actually did it, but there was some network issue. It was not going, so I had to restart the system. Okay, I will send it to you because so much data is there here. Okay, no problem. Yes, you guys are clear with today's concept, everyone? Are you guys clear with today's concept? You guys understood what is thread, how it is executing, parallelly how to execute two threads, how to create threads. Okay, next class. Okay, sure. Yeah, fine. Okay, guys, that's it for today. And you guys can leave for today. Okay, one last class we will take on the Wednesday or Monday or Tuesday. Monday or Tuesday or Wednesday. Any day I can take. Monday, Tuesday you will have no class, but if I want to take, I will take. But so you guys want leave on Monday and Tuesday? Shall I take on Wednesday for you? You guys want leave on Monday and Tuesday because there is a leave for you guys. Okay, fine. So Monday, Tuesday there will be 3 days continuously. Sunday, Monday, Tuesday. Sunday, Monday, Tuesday, 3 days you'll have leave. Go through the Java programs concept, everything. Okay. We will revise Java take on Wednesday. Yeah, sure. You can revise Java and the last concept thread deadlock and some more program we will do on next class. Okay. Yes, guys, that's it for today. And this is the last second class. Okay. And the last class we will do on next class on Wednesday. Okay. Have a great evening, guys, and happy Navaratri. Take care. Bye. Good night.